Hello students, welcome back to my YouTube channel Puri Tutorial, and today in this video I am going to integrate this integral, which is one of the important topic from BSc Maths. So let's start the proof. How to integrate integral over 0 to pi by 2 log sin x dx. Let's see. So firstly we are going to use one of the property of definite integral, that is integral 0 to a fx dx is equals to 0 to a f of a minus x dx. Okay, so we are going to use this property here. So let this integral capital I 0 to pi by 2, by using the property we can write log sin a minus x. The value of a is pi by 2 minus x dx. So we know sin pi by 2 minus x is equals to cos x. So this can be written as 0 to pi by 2 log cos x dx. So initially we assume this integral capital I. After applying the property we get this. So by adding, consider it equation 1 and this is equation 2. By after applying the property, adding 1 and 2, we get I plus I, 2I left hand side, right hand side 0 to pi by 2 log sin x plus log cos x. Again we are going to use one of the property of logarithmic function, that is log m plus log n is equals to log m into n. So this can be written as 0 to pi by 2 log sin x log cos x dx. Okay, so I am going to write the property also if you feel any difficulty. Okay, now let's modify a little bit. This can be written as 2 sin x cos x. Okay, so we are going to write 2 sin x cos x upon 2 to make our integration more easy to solve. 0 to pi by 2 log 2 sin x cos x sin 2x, I hope you know the formula, upon 2 dx. Again we are going to use the formula of log m upon n is equals to log m minus log n. So we are going to write it as log sin 2x minus log 2 ds. Now we are going to integrate each term separately. Log sin 2x minus 0 to pi by 2 log 2 dx. Now 0 to pi by 2 log sin 2x, write log 2 outside, 0 to pi by 2 dx. 2I, consider this integral I1. We are going to solve this integral later. Solve this log 2, integration of this is x, by after putting the limits we get pi by 2. Okay, so this can be written as 2I I1 pi by 2 log 2. So give it equation 3, I guess. So let's solve the I1. So here we are going to solve this integral separately. So we get I1 is equals to, we are going to put or assume 2x is equals to t. Put 2x is equals to t. Differentiating both sides we get 2 dx dt. It means dx is equals to dt upon 2. After changing, so after putting this variable t, the limits get changed accordingly. Like if we put x is equals to 0, t becomes 0, and if we put x is equals to pi by 2, t becomes pi. So let's change the limit also. 0 to pi log sin t dt upon 2. I1 is equals to, write this 1 by 2 outside of the integration, 0 to pi log sin t dt. I1 is equals to 1 upon 2. So after this we are going to apply one of the property of definite integral. Okay. To use that property we are going to change something here. We can write it as 2 pi upon 2. Okay. Log sin t dt. Okay. I am going to write the property here, 0 to 2a fx dx is equals to 0 to a fx plus f 2a minus x dx. So we are going to use this property here. Let's see. I1 is equals to 1 upon 2 bracket integration 0 to a. So here a is 2a. A is pi by 2. So 0 to pi by 2 f of x that is log sin t plus log 2a minus x. 2a minus x is 2 pi by 2, that means pi, log sin pi minus x dt. We bracket closed. Okay. I hope you don't feel any difficulty in this step. After that I1 is equals to half. This can be written as 0 to pi by 2 log sin t plus log, this is nothing but sin pi minus t is sin t. So this is sin t dt. I1 is equals to half 0 to pi by 2 log sin t 2 sin log t 2 log sin t dt. 2 get cancelled here. It becomes I1 is equals to 0 to pi by 2 log sin t dt. You may change the name of the operator also. We just simply write t is equals to x here. Nothing else. Doesn't matter. Whatever the name is. Okay. So this I1 is equals to this. And if you notice, this is nothing but this is our I itself. Okay. This is the question itself. So we assumed it earlier capital I. So we are going to put this integral capital I in equation 3. Here we are going to put I1 is equals to I here. Now from equation 3 we get 2I is equals to I1 minus pi by 2 log 2. We get I1 is equals to I. We are going to put I here minus pi by 2 log 2. 2I minus I is equals to minus pi by 2 log 2. So we get it 0 to pi by 2 log sin x is equals to minus pi by 2 log 2. And one more thing. I want to say one more thing. If we going to integrate log cos x 0 to pi by 2 log cos x dx, the answer will be same, minus pi by 2 log 2. So as I said, if you want to integrate 0 to pi by 2 log cos x dx integration, the answer will be same. But how? Because if the question is log cos x, after applying this first property of definite integral, here we get 0 to pi by 2 log cos x pi by 2 minus x. Cos pi by 2 minus x is sin x. So we get 0 to pi by 2 log sin x dx. So again, as it is, same procedure will be followed as we have done in log sin x. 1 and 2 equation will be get added. We get the same 2i here. There's nothing difference between the process. So we get the same answer. And this equation, the I is equals to minus pi by 2 log 2 is also used it as formula, directly in some integration also. So I hope you like this video. If you like this video, please hit the like button, subscribe my channel, and don't forget to press the bell icon. Thanks for watching this video.